Welcome back to the channel, everybody. It's been a little bit, but I've been working on a lot of things behind the scenes. And what I want to show you right here is a couple of the batteries that I'm going to use on this project. I've bought 12 of these batteries. Right here, you can see just two of them. These batteries are they're out of an Audi Q5 PHEV, and these are the M modules. They're 13S P1P, and they're pretty slick. You can see they got 13 cells. I don't know much about the cells individually, but you'll see that it has a built-in battery management system. Granted, it's proprietary. I bought these from a YouTuber that you guys might be aware of. His name is Jag35. He reviews batteries and does a lot of stuff with lithium batteries. Anyway, he was pretty excited about these videos on his site because he was able to remove these boards and make his custom circuit board to use the screw locations and everything, and then use an external battery management system. That's pretty cool, but as far as I'm concerned, there's already a battery management system on here, so I would very much like to use the one that's on here. So in this video, we're going to talk about these batteries a little bit, and more importantly, I am going to try to charge just one of these cells separate from all the rest to see if it is going to balance automatically without any external signals, okay? Because there's a connector on here that has CAN. It's got some other voltage requirements and whatnot. But I'm just curious if this thing's going to do a balancing without having to worry about any of that. I will reverse engineer it if I have to in order to utilize this board. Because, I mean, look at this. There's like at least $50 worth of components on this board that I would just assume not have to supply separately. I would like to utilize them. So I'm just real curious to see if the battery management system is going to kick in without any signals and do balancing on these cells. Okay. So first, I'm going to go through. I'm going to measure the voltage on the cells in one of these packs and show you that I've already done this, but I'm going to show you that they're all very equal right now. But I'm going to go ahead and charge one of them way out of bounds compared to the others, and just do we're going to wait and we're going to see if it does its thing, and I'll be able to tell by these resistors getting warm if it's trying to discharge the energy from one of the cells because it doesn't match the others. So that's what we're going to do now. Okay. Okay, so now you got a better view of the battery and the bench-mounted voltmeter I got going on right here. So here we go. Cell 1, 3552. Cell 2, 35523. Cell 3, looking very similar. I'm just going to go through these and you can watch. Okay, so I just did every other cell, and you can see they're all very close. I'm not going to waste everyone's time by looking at absolutely every single cell. So they're at 3.55. So what I'm going to do now is I'm going to apply a voltage to this very last cell here. I'm going to do 3 amps, and I'm going to charge it for a little bit just to increase the cell voltage of this one cell, okay? This unit on the bottom is a 3 amp power supply. And I have it set to 4.2 volts, which is the maximum charge voltage of a lithium cell. The cell I'm about to charge is at 3.55 volts right now. You can see it's set at 4.2 volts, 3 amp charge voltage, and I'm turning it on now. It's charging at 3 amps, and you can see the voltage. Even though it was at 3.55, it's set at 3.69 current voltage, and it's going to go up as it charges. So I'm going to let this record, and I'll play back in high speed. I don't know how long it's going to take. It's a good-sized cell. I don't know the specifications specifically on this individual cell, but let's just let this record and see what happens. Now you can see on the top voltage meter, you can see the voltage change in real time. It's pretty slow. That means it's got decent capacity if it's taking this long to charge at 3 amps. But at any rate, we'll let this thing go. I'm going to take it to like 3.8. I just want this cell to be way out of range compared to the other cells, and then we're going to see if I disconnect from power, if it's going to self-balance. Okay, so I stopped the video for a second, not for very long. But what I'm going to do now is I'm going to time the voltage change to correlate how long it's going to take to get to the voltage I want to get to. So I've got a little stopwatch that I started on my PC here. And at 5760, I'm going to start it. Right there. So when it gets to 5770, I'm going to stop it. And based on that time, I'm going to figure out how long it's going to take to get 3.8 volts. And then I'm going to stop the video and I'm going to go do something else. Because I don't particularly like staring at this voltage taking a long time to go up. So there you go. 66, 67, 68, 69, 70. Okay, so that's 41 seconds. Let's do some math while I got you on video for fun. All right, I want to go to 3.8 volts. We are at 3.5775. The difference is 0.22. Divided by 0.001 equals 222 times 41 seconds. Divided by 60 seconds in a minute. 152 minutes divided by 60 minutes in an hour, 2.5 hours. All right, I'm going to stop the video and I'll see you in 2.5 hours. Okay, we're back. I actually got tired last night. It was about 12 when I started the video and I didn't want to wait 2.5 hours last night. So I turned the charge voltage down to 3.8 volts. and just let it go overnight. So right now we're at 3.7981 volts. So I achieved what I wanted to achieve there. So this one cell is out of alignment, we'll say. It's just got a different charge voltage than the other ones. You can see we're at 3.8-ish right there, and the one next to it is still at 3.55, as well as all the rest of the cells. So now what I'm going to do is I'm going to disconnect it from the power, and I'm just going to let it set, and I'll check it again probably tomorrow to see, but I have suspicions that it's not balancing without some kind of control signal. So if that's the case, then I'll just do some more research and hopefully figure out a way to reverse engineer the logic and the CAN bus, and figure out a way to make it run so we can utilize these battery management boards that are on the battery already. So that'll be the plan next.